Okay, so just a recap for yesterday. We looked at geometry series. Okay, now geometry series look like this, and then we stop at one equation. Okay, we stop at this equation. When we are processing geometric series data, straight away, if the question asks us to calculate geometric series data, straight away you can use this equation. Sn equal to A. A is the first number. A is the first number. Okay, first number in the geometric data. A times 1 minus R power n divided by 1 minus R. R is the ratio in the geometric. So if you look at this geometric series, the first number is A, second number is AR. So you take the AR divided by A, the R is there. This is the R, the ratio for the geometric series. Okay, so again, if you're not sure what is geometric numbers or geometric equation or geometric series, you can turn back to your advanced mathematics textbook, right? So, or you should still not sure, you can go back to the previous video to listen and try to digest. Okay, so this is where we stopped yesterday. So if R not equal to 1, we can use this equation. Okay, so if R equal to 1, yesterday we looked at two scenarios, right, for geometric. If R equal to 1, our geometric series will become infinity. So when R equal to 1, geometric series become divergent. Okay, remember that. If you see a geometric series or geometric pattern, and when you have R equal 1, you'll get divergent series. So you won't get one fixed number there. So again, for your info, just to remind you, this module we always look for convergent data. All right. Now, what happened if yesterday we stopped at what happened if R not equal to 1? If your R equal to 1, you can use this formula to calculate the sum of all the numbers in the geometric series. Okay. We have touched this. We have explained why when the R not equal to 1, we can use this one. Now let's look at what happened to your R. What happened to your R in the geometric series? What happened if your R is 1 to minus 1? What happened if your data, you know that your R cannot be 1, right? Cannot be 1, because once your R become 1, you will get divergent data or divergent series. That is not what we want, right? You will always get negative if you add all the, you will always get the infinity as the sum of the numbers. So that is not what we want. We want to get a convergent. So here, the second R value, it should be what happened if your R is between 1 and minus 1, meaning if your R is less than 1, it meaning you get 0.99 to negative 0.99. Okay, so it cannot be 1. Once the R get 1, you get infinity already. Infinity means divergent. That is not what we want. You want to focus on convergent data. Okay, so R is a small decimal number, for example 0.999, right? But it's not 1. To infinity. Okay, so what happened if your R, you try to look at this equation, if your R, you substitute, your R is 0.999, 0.999, you increase the n become infinity. You try to press your calculator 0.999 power, let's say 1000. What do you get? 0.999 here, this one. If your R is 0.999 power, let's say 1000, what do you get? 0.999 power 1000. What do you get? Nizam? What do you get? Nizam, are you there?
Dạ, rồi đã cậu đi.
Okay. Edmund, you calculate what happened if your R is 0.999 power. You calculate Nizam will calculate 1000. You calculate 10,000. Edmund, you calculate 0.999 power 10,000. Shakir, you do calculation for this one. 0.999 power 10,000. Yeah, okay. Nizam, what do you get?
For 0.999 power of 1000, get 0.367.
Okay, 0.367. Let's wait for answer from Edmund. Edmund, you do power 10,000.
0.
0.999 power 10,000. You get 0. Can you expand the decimal place? At least 4 decimal place or 5 decimal place. What do you get?
0.5. 0.53.
Are you sure? You take 0.999 power 10,000. Do you know how to use calculator, Eman? Okay, Edmund, you take your time. Shakir, 0.999 power 100,000. What do you get? Shakir, I cannot hear you clearly. Check your mic, Shakir.
Hello.
Yeah, check your mic. Okay, so what is the answer?
3.54 times 10 to the power negative 44.
Are you sure you get the correct answer? I'm asking you to do 0.999 power 10,000.
100,000 you said.
Oh, sorry, 100,000. Yeah.
Yeah, it's 3.5.
Are you sure, Shakil, you get 0 point something?
No, 3 by 3 like long
0.999 power 100,000, right?
Yeah.
So what do you get? 0
3.
point?
3.53, sir. Times 10 power of negative 4. Coming like that.
Correct. Okay, good. So as you can see, if you increase your number, if you increase your n number, yeah, the number will close to 0. It becomes smaller and smaller, but it will clear to 0. Okay, so this is how you estimate the pattern. Edmund, can you tell the class what is the 0.999 power 10,000?
4.51 plus 10 power negative 5.
Okay. All right. So, but anyway, the point of asking you all these questions is to see what happens if the R is less than 1 and less than minus 1. And you increase the n to infinity. You'll see that the number will near to 0. Okay, the next one. I will move a little bit faster. Huh? So if you put the limit there, if you put the limit in front of the series, meaning you do computation, you calculate until infinity, you will get what? Okay, so this is the conversion that we calculate before, meaning we can change. Okay, we can change this equation. Right, we can change this equation above in the blue color equation. Can you see it? We can split this one into the first one and the second one into this one. Okay, we rewrite this equation, or the same as Sn equation, into the blue color equation, meaning we start to apply the limitation law. Okay, the limitation law. So we rewrite this series equation into the blue color. So we can write limitation blue color minus limitation the second blue color. Okay, so basically we are just rewriting this one into here with the limit. Any question so far? Any question why this one you can write this one? Edmund, you understand why this one will become this one?
No, sir.
Okay, Nizam, you understand why this one become this one? Nizam?
Yes, sir.
What do I ask you just now?
You say you put limitation and then split into 2.
Okay. I'm asking you whether you understand this one to this one or not.
Yeah, I understand.
Okay. Shakir, you understand this one to this one?
Yes, sir.
Okay. Edmund, go and rewatch the video where I talk about limitation law. Okay, go watch the video. This one, actually, we just rewrite this one in this form, and we put the limitation here and here. So that's why this one will become this one. Then you calculate. As your limitation, as just now, I asked you a question to do the calculation with the calculator. You know that r power n, if you increase until infinity, you get 0. So you look at this second component. If you take this one times this one, you know that your r power n equals 0. So something times 0, you get 0, right? This one you can cancel. And you only leave out this one. So we can cancel that one. And the answer, you will get limitation n to infinity, a divided by 1 minus r. Why do we still get a divided by 1 minus r? Because inside this equation, we don't have n. There's no n there. So you can straight away write the answer will be a divided by a minus r. Any questions so far? Edmund, any question?
No, sir. No question.
Yeah. All right. Now, by having proved to you that from here to here, meaning if your r is in this range, you can write if you do calculation using a limitation for the sum of the series, means you combine all the numbers. For geometry series, you can use a divided by 1 minus r. Okay, you can, first equation, this one, when your r not equal to 1, you can use this one. When you know that the numbers of your r, you know your r value is 1 to negative 1, you can use this equation to calculate. So you can write the equation if you control your R, this one, you know that your R, you know that your denominator cannot be 0. So your R value must smaller than 1. If equal to 1, you will get 0 because you divide by 0. So we don't want 0. So we don't want to get infinity, right? So so your R value, we control it to be positive value. You can see that this statement, your R have a goalpost there. It means that we always make sure it is your R will less than 1. So that we always get one number from this equation, one solid number from this equation to meet the convergence criteria. So we can write another equation for geometric series. If the R is between -1 to 1, you can use the blue color equation. Okay, so this is there are two equations now. If your geometric equation, your R is not equal to 1, you can use this one. However, if in the question you know that the range of R is between -1 to 1, straight away you can use the blue color equation to calculate. Okay, so I highlight the equation for you. This is very useful when it comes to test or final exam. Okay, straight away you write this equation, you copy the question, write this equation, substitute the A is the first number, go and find the R is a geometric series. So again, if you're not sure what is geometric series, open up the advanced mathematics textbook, go and understand what is geometric series, how to find the R. Okay, so this one is a very basic in a geometric series chapter. So you straight away use this equation to solve for series. Okay. If your R, okay, if you use this equation, you have the goalpost R, or this your R is less than 1, it will become convergent. But however, if your data is less than 1, this equation will become convergent. Okay, if this one less than 1, your R is less than -1. Okay, so it will become convergent, divergent. Sorry. So when R more than 1, if R more than 1, it will become divergent. Okay, if your R more than 1, it will become divergent. Okay, just check with this equation. What happens? You change your R less than -1. What happens if your R more than 1, and then you increase your n to infinity? If you get the number, you add all the number together, you get infinity, it becomes divergent. If you get one solid number after you substitute the n become infinity, very, very big power, you get one number, means you get divergence geometric series. Let's look at one example. So this example 13, the question asks you to find the sum of geometric series. Okay, now already tell you this is a geometric series, and the previous slides already give you the pattern of the equation where A plus AR plus AR2 plus 3 dot equal to this green color equation. What you do, the next step is to rewrite this equation. Rewrite this equation, this whole equation, A plus AR until here. Copy this one. Put in your answer sheet. You get 1 mark for general. You get 1 mark for showing you understand which equation to use. You are using the correct equation for geometric series. So again, you look at the question. Okay, of course, this is a tutorial question. All right, this is a tutorial question. So it will be very direct, tell you. When it comes to test or exam, you won't see we are telling you it is geometric series. You have to analyze yourself. You look at the data. You have to analyze yourself whether this is a geometric series or not. Okay, yeah? So again, you need to flip to advanced mathematics class or mathematics 1 notes to see how to process geometric series, right? Again, this already covered in Maths 1. Huh? So I just help you to recap the fundamental concept for the following power series chapter. I just build your foundation. Huh? So, and I break it in for you. So you look at the question and you identify this one is a geometric series. I already skipped the identification. Huh? So there is a step there. So I skip the step. Straight away, I know this one is geometric series. So I copy the equation for a geometric series equation. All right. So when you write this one in your answer, you get 1 mark for this. Just copy and put in your answer. If this one you confirm that this is a geometric series, you write this one, you get 1 mark in your answer. After that, you know that when the series, this one series, if this series is a convergent, you can write this equation. All right? Because just now in the previous slides, you have this equation and this equation. So if you are going to do convergent answer, you use this equation. What is Sn? What is this Sn? Sn equal to this one. Right? So you just substitute this one in the limit there. You get this one, right? So that's why we can write sum of a r n minus 1 equal to a divided by a minus r. Basically, this one you can copy from the PowerPoint slides or from the today lecture. Okay, again, just to warn you or just to remind you, in test you don't have time to rewatch my video, right? Because you're only given a limited time, and we expect you to solve the question. We already calculate the time that you need to solve. So if you go and watch my video and flip to my PowerPoint slides, you don't have enough time to solve. So you need to do revision before the test or final exam. Huh? So the notes only help you to the notes that I give you or PowerPoint that I give you, it just help you to polish up the concept. All right. So so you have to know lah. Huh? So you write this one, copy in your answer for geometric series, you get 1 mark. You copy this one, you put in the answer, you get 2nd mark. So 1 or 2 mark actually is a free mark. Huh? Actually already help you already. Only what you need to do, just write these 2 equations in your answer. If the data given to you is geometric series. So it's your homework to go and find out why this one is a geometric series. Huh? So how to know the first term is 5? How to know the first term is 5? What mean by first term? First term means first number. Okay, Nizam, you look at this equation. Look at maybe this one. Maybe this one. Okay, Nizam. So this question for you. When you have the first term, what is the n number?
N number 0.
No, I mean, yeah, I mean the answer for this one you get 0. But if you're talking about the first number, n equal to 1, right?
N equal to 1 minus 1.
N equal to minus 1, you get 0. So for the first number, you have to look at the general equation. So general equation, n equal to 1. 1 minus 1, you get 0. So r power 0, you get 1. That's why you get a.
Yeah.
So that's why you get this full equation. Then you compare the red color equation and the blue color equation. So you can get a equal to 5. Okay?
Yes.
All right, good. Now, Shakil, this is a second question for you. This is a question for you, Shakil. Nizam already answered a equal to 5. My next question for Shakil. What is AR? AR equal to what? You compare side by side. Huh? A equal to 5. Now my question is, Sakil, this question for you. AR equal to what? Shakil, are you there?
Yes.
So AR equal to what? Just side by side. I just put the equation side by side. If A, this equation, if A, sorry, I cannot go further because of the green screen limitation. The far A, the single A there equal to 5. You make comparison side by side. AR equal to what? Shakil. Shakil, I can't hear you.
For the R or do we just...
No, I'm asking you what is AR equal to? You put side by side, the first number A equal to 5. So what is AR? The second term is AR, right, Shakil? You understand when I mentioned second term equal to AR? So what is AR? What is AR? What is AR? What is the second term in this question?
No.
What's your question? What's your answer? I cannot hear you clearly.
Negative 10 over 3.
Correct. Okay, Edmund, this question is for you. What is A power 2 equal to? The third term inside this. If you compare side by side, I'm asking you the third term, the third number. AR power 2 equal to what?
20 over 9.
Positive 20 over 9, correct?
Yes.
Okay, and so on. So, I assume you know why I can say R equal to negative 2 over 3 because of geometry. The common ratio R equal to negative 2 over 3. How to get 2 over 3? You take the second number divided by the first number. You take the third number equal to third number divided by second number. You'll get negative 2 over 3. Okay, I'm going to skip explaining about the common ratio. Go to advanced mathematics textbook to find how to find common ratio for geometric series. I assume you already know from mathematics 1. So you put the three common there, three common scenario there. All right. What happens if R less than 1? What happens if R less than -1? What happens if R equal to 1? So you know that for geometric, the only one that is convergent is the first one. Your R must less than 1. Second R and the third R is divergent. So you look at this one. You look at the R that you find from this data. The R is negative 2 over 3. Negative 2 over 3, there are 3 sets of data to compare. Your R is less than 1, correct? This one, negative 2 over 3. Edmund, you understand why this one you can use the first criteria? Do you understand?
Yes, sir.
Okay, good. So that's why we know that from comparing the criteria just now, the slides that we just explained just now, there are three areas that you can go. The value of R, you have 3 sets. First set is that if your R less than 1, you get convergent. If your R less or equal to -1, you get divergent. If your R more than 1, you get divergent. So there are 3 scenarios for you to choose. So from the exercise itself, from the example 13, you manage to find that your R actually is negative 2 over 3. So negative 2 over 3, you compare the 3 scenario you have there. So negative 2 over 3, 4 in the first one. 4 in the first one. because this value minus 2 over 3 is less than 1. Okay, this one is minus 0.75 is less than 1. So this geometry set is convergent. What happens if you are convergent? You can straight away use this equation to find the answer. So A already given, explained by Nizam just now. A equal to 5. R is the ratio in the geometric series. How to find R? You take the second term, second number divided by the first number, or you take the third number divided by second number, or you take the fourth number divided by third number. You will get the same R. Okay, R is a ratio between the numbers. Okay, R is negative 2 over 3. You substitute. Okay, I help you with this derivation or these steps. A equal to 5, R equal to negative 3. You can do calculation, right? Shakir, what is the answer for this one? What is the sum of geometry for this series if you use this calculation? What do you get? The rest, Nizam and Edmund, you can help to justify, help to check Shakir's answer. Huh? Shakir?
Three, sir.
Correct, 3. Nizam, is it correct?
3, sir.
You also get 3.
Yeah.
Edmund, what do you get? Edmund?
Oh, 3.
3. Okay, answer is 3. Huh? So, how do I mark the answer if this kind of question come out in a test? Okay, this one won't come out in final exam because this one too easy already. Okay, so if this come out in your test, or sometimes I give you quiz to solve, this give you 1 mark, this one give you 1 mark. Basically, 2 marks are free mark. It's just seeing whether you understand which is the correct answer equation to use. Basically, you can copy from the PowerPoint slides, or even from the from your notes. This one, you copy this one, put your answer, copy this one, put your answer, but these two only apply for geometric series. You score 2 marks, you substitute the value, you write A equal to 5, you write R equal to negative 2 over 3. This set, this whole set, you give you another 1 mark. You substitute the value, you get 1 mark. You do the calculation steps, you get 1 mark. You calculate, you punch the correct answer using your calculator, you write the answer 3, you get 2 marks. 1, 2, 3, 4, 5. This answer give you 5 marks. Okay. I seen before student, even he write the wrong equation. He write A. If you're given a geometric series, the student even copy the wrong equation. A, R, N, he write positive 1. So he lose the first mark. This one, he copy wrong again. He write A, R, N plus 1. He write this one also wrong. Lost the second mark. He substitute the correct answer. I give him 1 mark. He press the calculator. He get the basically because he's copy from the top, because the student accidentally copied the wrong formula. He write ARN plus 1. I'll straight away give you a wrong mark. Basically, this question, the student only score 1 mark for calculation. Okay, this is how I mark. So let's say this is a 5 mark question. 1 mark equation, 1 mark equation, substitution calculation 1 mark, answer 2 mark. All right. So is there another way you know that this is a convergent? Is there any way you know that this is convergent? you can do the table. Okay, you can do the table. Of course, this is more lengthy. I won't expect you to use table, right? So you can use the series that we explained just now. You add the first number n1, the first number 5. If n equal to 2 means you add two numbers together. You 5 plus negative 10 over 3, you get 1.666. If you add the three number together, you get 3.88. You add the fourth number together, you get 2.407, and so on. As you can see, the number actually, if you plot in graph, this is the pattern you will get. You will see that the number actually get nearer and nearer and nearer to 3. That's why we can say this geometric series is convergent. Okay, Nizam, you agree? Nizam, you agree? This one is convergent?
Yeah.
Okay, good. Any questions so far for geometric series? Any question? Raymond, any question?
Yes, sir.
Okay, good. Let's look at one more example, then we go for a short break. You look at the question, example 14. Show that the series 2 power 2n 3 negative 1 is a convergent or divergent. Okay, you look at the question, it asks you whether this is a convergent or divergent. So how do you solve? Go very fast. You look at the question and you see whether you can group under geometric pattern. Okay, what mean by geometric pattern? This one. This is a geometric pattern for series. See if you're able to write the pattern or the final equation in this pattern. So that's why when you look at the question, actually there's a way to test you. So are you able to write the red color formula 2 power 2n 3 minus n in this form? So basically it just tests you whether you know how to rearrange the exponential equation into this pattern. Okay, so how you write the equation above, this one, you can write in this term. Okay, equation above 2 power 2n, you can write as 2 power 2 and then you put a bracket and power n. 3 1 minus n, you can write as 3 negative n negative 1, because negative n negative times negative 1, you get 1. You can transform this equation into this form. And because exponential negative 3 negative something, it means that every time you have an exponential negative something, it means it's a divide. So you rewrite this 3 power negative n minus 1 as a negative number, as a division number. All right, so divide with this one. Basically, from the top to this one is actually fall under advanced mathematics algebra equation. Okay, so or exponential numbers. So you rewrite the exponential negative as a denominator. Next, you do the calculation. 2 power 2, you get 4. Then continue to carry the n. Then this one you continue to copy. Are you able to see the pattern of this one and this one? Are you able to see? Okay, continue to give you the answer. There is a way to modify this kind of question. 4 power n, again we do magic here. Magic means we add something in the air where actually you do not do any changes to the numbers. As you can see, we do one magic trick here. We do +1, -1 on the exponential component here. Okay, basically +1, -1, you get 0. So basically you just add something in the air just to transform the equation into this form. After you write this one, you can combine, okay? You can combine and rewrite as 4 divided by 3 n minus 1 times 4. Okay? So this one, do you guys need me to explain how to get here to here? Can means you need lah, correct?
Yeah.
Okay, so you look at this one, you add something into air, right? You do some magic here. N plus 1 -1 basically is equal to n lah. But if you do n plus 1 -1 and you compare to the bottom one, what do you get? Bottom one is -1, right? So you pull the +1 to the front. You push this +1 to the front, and then you pull n to the back. You'll get +1 and -1, correct? Then you have the same pattern top and bottom. Basically, because you pull the +1 to the front, you get 4 like this one. Because 4 is what? 4 is 4 power 1. 4 power 1 is this one. And this one is basically is 4 and -1 is here. And 4 and -1, because just now I pushed the +1 to the front, and this one, and it become n -1. Basically, you just rewrite your 4 into this form. Okay, 4, you push your n to the back, 4 power 1 plus n -1 actually is the same as 4 times 4 power -1. Do you see it? And then you didn't touch anything on 3 power n -1. You didn't actually touch it, but you combine 4 n -1 and 3 power n -1. Basically, you can factor them together and power n -1. Shakir, do you see the logic here to here? Nizam, do you see the logic here to here?
Yeah, I understand.
Okay. Edmund, you okay? Here to here.
Yes, sir.
Okay, Shakir, are you okay? Here to here. Shakir, are you there?
Yes, sir.
Okay, now you see it. Okay, again, if you're weak in exponential chapter, please go and check your notes in advanced mathematics under exponential chapter. Exponential something x power something x power a plus s power b. What happens if you combine these two together? That one under exponential chapter. Go and visit that chapter. So I assume you already know that one. Okay, once you get this one, okay, once you get from here to here, all right, here to here, can you see the pattern, this one and this one? Can you see? Can you see the pattern? Nizam, what is your A? You compare the blue color and the red color. What is your A?
A is 4.
R?
4 by 4 over 3.
Correct. And this one same lah. Okay. Now the next step, once you compare the blue color and the red color, the next time the next step is to see whether it's converged or diverged. Just now we have three scenarios. Three scenario, we look at R. So this one, R is more than 1 or less than 1?
More than 1.
More than 1. So more than 1, it becomes divergent. Okay. More than 1 is divergent. So how do we give you marks in this kind of question? This is involve lots of steps. I just explained to you how do we give you marks. First, you write this one. You write this one, this equation, or you write these two equations. You write this one, you write this one, you get 2 marks. Then you know that you need to rewrite this one in this form. So what you do is that you rewrite 2 power 2n 3 minus 1 equal to this one, and then you slowly do the tricks here. Here to here you get 1 to 2 marks, and then the rest is just you compare to the 3 criteria. You explain that your A is 4, A equal 4, you get 1 mark. R, you write R equal to 4 divided by 3 because you compare this one and this one. Here, if I'm generous, I'll give you 2 marks here. And to explain whether this is divergent or convergent, you look at your R. R is more than 1, so it is divergent. So this geometric series is divergent. Okay, let me stop here. Let me end the recording.